So this skill might be tough for you, and so I encourage you to go to the resources page and practice it so it becomes a little bit easier. But this is the extent of logarithm stuff that we need to know. We don't need to know how to change the base. We don't need to know how to do like the product rule or the quotient rule with these guys at all. We just need to know how to convert back and forth. So there's a lot of stuff you learned in 10th grade that you don't have to use here, which is pretty nice. Okay, so we want to write the equation in the form of x equals. In other words, we want to isolate for x. At the beginning, of course, it's going to be straightforward. So if I want to get x out of the exponent, I have to undo the exponent piece, right? Just like when I'm like, I need to undo the addition, so I need to subtract on both sides. I want to undo the exponent piece here so I can get x by itself. So how I undo an exponent is I have to use logarithms. I start at the base, I do my spiral, and I turn it into a logarithm such that x can get out of there. So log base 2 of y equals x. Now it's in the form x equals. Technically, it's a little bit backwards. I could rewrite it by just putting the x equals over here, and then just, that's just log base 2 of y. That's the most straightforward problem in this example, and so the rest of them are going to have a few more steps. But once we can just get to this piece, that's how we go through the thought process in our problem solving thought process of how do I get x out of an exponent? I need to undo an exponent. How do I undo an exponent? Logarithms undo exponents. That's the thought process when we're problem solving. We're asking ourselves, what's going on here that I need to get rid of? How do I get rid of it? And then go through with the process. Okay, here again, I've got x in an exponent. I need to get x out of an exponent. So how do I undo exponents? Logarithms. Let's start there. To-do. Log base 2 of y equals 3x. Now, we've definitely gotten x out of the exponent, so that's like a kind of a weight off of our shoulders, right? Okay, okay, at least x isn't in an exponent anymore, but I still don't have x by itself, right? I still have x being multiplied by 3. So we're still asking ourselves the same question. How do I get rid of 3? 3 is being multiplied. How do I undo a multiplication? I divide both sides by 3. So divide by 3 and divide that whole thing by 3. So then it becomes log base 2 of y all over 3 equals x. I just have, I think it's like from being a math student for a very long time in university, I really don't like having it equals x. I like it being x equals. And so I always flip it around, even if it's just a few extra seconds of flipping it around. It's just because that's a more common notation and a nicer notation for a systematic process for me. Okay, so the extra step that we had to do here is once we got it out of the exponent, then we were able to divide and get rid of the extra pieces going on. Now we're going to see in problem number 3, it looks different than the things we've been working on in the past, and it looks different in a way that we are going to have to do a different system. Always recognize what's the thing that's different here, and is that going to change the thing that I need to do? The thing that's different is that it's being multiplied by 3 on the outside. So remember when we're undoing for variables, we follow the process of SADMAP, right? Not PEMDAS, but SADMAP. PEMDAS is for when we just have a bunch of numbers and we need to solve for what that number actually is. When we have variables and need to solve for variables, we use the process of SADMAP, which tells us what to undo first, right? We always undo the subtraction addition, and then we undo the division multiplication, and then we undo the exponents, and then we undo the parentheses. So here, we only had exponents that we needed to undo. Technically, this multiplication was in parentheses up there, so we saved it for last because the parentheses, right? It was isolated up there in something else, so it was a parentheses situation. Here we have a multiplication, and then we have an exponent piece. So we should undo the multiplication first. How do we undo multiplication? We divide. Divide both sides by 3. Y over 3 equals 2 to the x. Now I can say, okay, the only thing that's going on over here is an exponent situation. I need to undo the exponent situation, which is a logarithm. Log base 2 of y over 3 equals x. And now I've got x equals. Just ignore my obsession with it being in the correct order there. And you could leave it like this previous one and it's totally fine. Okay, so a different extra step that we had to put in, it had to go before because of this SADMEP process. And so now we're going to see it again in example 4. I encourage you to stop here. I won't have you type it out because typing logarithms on PlayPosit is difficult. So, but I will have you just try this on your own and double check. Okay, SADMEP. We need to undo subtraction addition. There is no subtraction addition. Done. Then we need to undo division multiplication. Well, it is being multiplied by a half, so I need to divide by a half. In other words, multiply both sides by 2. If you divide it by a half, that's fine. It just doesn't look quite as nice as multiplying both sides by 2. So I get 2y equals, that 1/2 goes away because I multiplied it by 2, and then e to the 2x. Don't multiply 2 in the exponent because that's not how it works. Okay, now that I've done that, I pause and assess and say, okay, what else is going on? I've got this exponent piece and I've got x in the exponent. I have nothing else going on here besides the exponent piece. Well, and being multiplied by 2 up here, but as we talked about earlier, that's really like in parentheses up there in the exponent. So we need to undo the exponent. We know that log base e is our natural log, so we can just rewrite that as natural log of 2y equals 2x. Then I'm going to undo, I'm going to pause and assess what's going on. Well, x is being multiplied by 2, so now I can undo that multiplication because I got it out of the parentheses by it all being stuck up in the exponent. Now it's no longer all stuck up in the exponent, so now I can just say, divide both sides by 2. So I divide by 2, and I get the natural log of 2y all over 2 equals x. Do not divide the 2's out. 2y is trapped inside of this system that is the natural log, right? You can't just cancel that out because it's having division undo essentially what we know to be an exponent situation, and division doesn't undo exponents, so it has to stay in there. So just realize that 2y is trapped inside the natural log, so you can't cancel out those 2's. So x equals the natural log of 2y all over 2. Okay, these are things, systems that you do need to be held accountable for. It's very rare that we're asked questions about that in this class, but it's possible. The questions that we're more likely to be asked, and probably you're going to be practicing a lot more, are these types of problems where we have a situation, decibel levels in terms of functions that we create are logarithmic as a relationship because it deals with exponents, but because the relationship has x in the exponent or what we want in the exponent to undo that, it has to be logarithmic form. So it is an exponential type of relationship, but we write it as a logarithmic relationship. If that makes sense. The input is I, and I is the sound intensity. Awesome. Label my variables because I'm a good math student. D is sound. Is the sound intensity level. So I'm going to say sound level. Notice I had to pause and read it because it says sound intensity, sound intensity. I'm like, wait a minute, they're the same thing. But I know that I wrote these correctly. So I know that that is what it says it is. And so what's the difference? It's the level as opposed to the intensity. So decibels is how we measure it. And so we say, okay, it's the level versus the sound intensity is the actual, like what is happening in terms of the sound wave, right? Or something along those lines. I is in watts per square meter, and sound level is in decibels. So if I see those units of measurement, it's going to be easy for me to match what goes where. A vacuum cleaner has a sound intensity of this. Calculate the intensity level of the vacuum cleaner. So here's where it might be easy to match up units of measurement. Okay, I need to plug this in for I, and then I need to then solve for D. Okay, so then that's D of 1.6 times 10 to the negative 5, which is 10 log of 1.6 times 10 to the negative 5 plus 120. Okay, so I can just, because it's not an X, right? I can just plug this into my calculator. 10 times, and my logs are above the 10 to the x. But it, see if I can turn up that brightness. So it asks for a base here, but I don't have a base written here. This is where we need to know that if we don't see a base written, it's an invisible 10. So that base there is 10, and then we do 1.6 times 10 to the negative 5, and then plus 120. So the main thing, the reason why I wanted to go through this with you is because I know that when you put this into your calculator, you might have paused and been like, wait, I don't have a base. And that's because the base, you do have a base, it's a base of 10. So we get 72.04. So for 3 sig figs, I'll do 72.0. And then put in that unit of measurement, decibels, it's about 72 decibels. A fire truck siren has an intensity level of 124 decibels. Find the sound intensity of the siren. I'll have you do this on your own. If it's hard for you to know what to plug in where, remember to match your units of measurement. So that goes in for D. And then if we want to find the sound intensity, that means we're solving for I. Okay, so then that's going in for D, right? So it's replacing the entire left-hand side. 124 equals 10 times log of I plus 120. You could numerical solve from here. You could also use the skills that we talked about of how do you get the I out of the log. So using all of these skills, you could subtract by 120, divide by 10, and then spiral out to turn it into an exponent form. Or you could just numerical solve. If you want to numerical solve, just go ahead and type it out right now. I'm just going to show you quietly how that would work for isolating by getting it out of exponent form. So for instance, if you have a TI-84 and you don't have numerical solve, this might be a process that's easier than doing y equals and finding the intersection. Although I think probably y equals and finding the intersection is best, is probably what you think is best. Spiral.